Okay, guys, we're going to have a look at example 12.1. Example 12.1. Okay, so it says the car on the left of the photo, okay, all these details, moves in a straight line, so rectilinear kinematics, such that for a short time its velocity is defined by this. V is 3t squared plus 2t. So what do you notice here? V is a function of time. What are our variables here? Velocity, V, and t. Okay, please take note of that. Where t is in seconds. Determine its position, s, and its acceleration, a, at t equals 3 seconds. And then when t is 0, s equals 0. Okay, so what do we have? We have v as a function of time. We have v equals 3t squared plus 2t. Vt, what are my variables? V and t. What's the question? The question is, what is the position s at t equals 3 seconds? So how are we going to solve this problem? Well, immediately we know, remember that if we've got position to velocity to acceleration, if we're going from position to velocity, we differentiate. From velocity to acceleration, we differentiate. From acceleration to velocity, we integrate. From velocity to position, we integrate. Okay? So what does that mean? So we want position, but we have velocity. So we're going to have to integrate our velocity. Okay? So that is the conceptual idea. If we've got velocity as a function of time and we want position as a function of time, yeah. So what do we want? We want s as a function of time. We are going to have to integrate our velocity to get to our position. Okay, so that's very helpful for us to understand. But if you're not at this point yet, what you need to do is look at the variables that are involved in the problem. We've got velocity, time, and position and time. So we have v as a function of time. We want position as a function of time. So we need to use this equation, v equals ds dt, that relates those variables to each other, v, t, and s. Okay? That's one of our fundamental equations, if you recall. And what is our velocity? Our velocity is 3t squared plus 2t. 3t squared plus 2t. So now what do? We separate variables. ds is 3t squared plus 2t dt, and we integrate between our limits. This would be 0 and s. This would be 0 and t. So we're going to have s is equal to t cubed plus t squared meters. Okay? So you should always try to get this in function form. We had v in function form, v as a function of time. Now we want position as a function of time. There we go. So now what is s at t equals 3? We just plug that in and we find s is equal to 36 meters. All right? So what did we learn here? We need to find the correct fundamental equation that relates those variables to each other. Or you just knew that in order for me to go from my velocity equation to my position equation, I need to integrate my velocity, which is exactly what we're doing here. We're integrating our velocity equation with respect to time. Okay? So our position is equal to that. Okay. All right. So that was the first one, is getting position as a function of time and solving for it at a specific time. The second one is acceleration. What is the acceleration at t equals 3 seconds? Again, we started with velocity. We want to get to acceleration. We need to differentiate our velocity equation. Okay, that's our velocity equation. We need to differentiate it to get our acceleration equation. But if you're not there yet, then just look at the variables. I've got v, t, and a and t. So I've got v, t, and a. I can use this equation A equals dv dt. So what did we say here? We want to differentiate our velocity equation to get to our acceleration function. So acceleration is just d dt of v. Okay, so it's the derivative of velocity with respect to time. And that equals 6t plus 2. That's our acceleration equation. Our acceleration equation at t equals 3 seconds is 20 meters per second squared. Okay? So I hope that helps. I can't really think of anything else to say here. As you can see, the acceleration here is not constant. It's not constant. Okay? It'll probably look something like this. That's 2. Is that right? Or would that be minus 2? Okay. But nevertheless, it's not constant. So that is our 6t plus 2. Acceleration is 6t plus 2. That's not a constant. If we're looking at our AT curve, it's not constant. Okay? So we've got our acceleration, we've got our position. Okay. Cheers.